Hi, everybody. Captain Al speaking. Good morning, good afternoon, good evening, wherever you are. Good to see a lot of my regulars here. This is Ftd-Pc Fs number 5 briefing. And at this point in the training, if you were a student sitting in front of me doing the training, this is the point on lesson 5 when you should be very familiar with the flight deck preparation, flow patterns, checklist usage, and some of the basic navigational practice. So this is kind of where we judge whether a student is ready to continue on for the second half of the syllabus. Because up till now, if you think about it, it's been primarily the flight deck preparation and doing the flow patterns and the checklists, and then being able to take off and do the takeoff procedures. All of that has been the basics, let's say. And then in the second half of the syllabus, we start to get into the more of the from lesson 6 on. We get more into the non-normals and non-precision approaches and missed approaches, and still the emphasis is still on setting up the flight deck and being able to do that, because again, we don't want to get into the full flight simulator and somebody doesn't know how to set up the flight deck in a timely manner. So we do flight deck cockpit preparations, the scan flow. We do the scan flow all through the 10 periods because we want to make sure the students are well ingrained in the being able to set up the flight deck. And so far we've been doing that in here and getting a little bit faster with it as we go from the lessons. And the last lesson, I ended up not saying anything going through the flight deck prep. On this lesson, on lesson 5, I'm going to skip the flight deck preparation because we're not together, you're not in front of me, you're not doing it. So I'll end up skipping the flight deck preparation on lesson 5, and we'll be in the hold short position for runway 32 left at Boeing Field, ready to depart basically for the lesson to Moses Lake. Okay, so let's take a look at the lesson objectives for lesson 5. This is going to be a flight from Boeing Field to Moses Lake. Surprise, surprise. We will have icing conditions present. So some of the lesson will deal with the adverse weather as far as icing goes. We'll have an LNAV, VNAV takeoff. We'll perform a static engine run-up due to the icing conditions prior to takeoff. And then there'll be more navigational practice. One thing I forgot to do last time that I'll do on this lesson next week is I forgot to discuss the progress page. I don't think I did that last week, and that was called for on that lesson. So we have plenty of time en route to do that. So we'll talk about the progress page in addition to some other exercises. We'll make speed and altitude changes using VNAV, and we'll do some more holding, but this time it's not going to be a present position hold. It'll be a hold at a VOR using the quadrant radial line, and then we'll be going in for an ILS approach to an auto land and then shutdown procedures. Here's the objectives again. Practice flight deck preparation. Well, we're going to bypass that because we kind of beat that to death. And again, if you were in front of me, I'd have you do it. But because you're not, we're going to skip that. And we'll come back to it. I think in lesson 6, we'll end up skipping most of it, but we'll go right to the part where we start the engines. And then there's a start problem, so we'll start there on lesson 6. But for lesson 5, we're just going to be in the hold short position of runway 32 left and take off and do the needle. I think it's the needle 1 departure. We'll have an intercept course to a waypoint along the way. We'll have an airway intercept that we talked about in the last period. Once we get to our cruise altitude, we'll do a cruise climb. We'll do a cruise, we'll change our cruise speed and then resume normal navigation or normal speed. And then we'll do a cruise descent and then have our holding. We'll do a route modification on the way into Moses Lake, and then we'll go direct to a waypoint. We'll set up our approach preparations for the ILS, and in the descent, moderate rime icing will be reported at a certain altitude, and we'll go to the descent page and put in our thermal anti-ice on altitude, which will have an effect on the top of descent point. Or if you're already in the descent, it would have the effect of changing the vertical profile based on the fact that the nacelle anti-ice is going to come on at a certain altitude. And that means the approach idle is bumped up, and that means it's going to take longer to get down. So generally, if you're prior to the top of descent, that point will move back. If you're already in the descent, in the VNAV descent, then you would probably show high in the path after you put that in. Because the system would recognize that if the nacelle anti-ice is on at a certain altitude, that the approach idle is going to be bumped up, and that's going to take longer to get down. So we'll look at that as part of the approach preparations, and then we do the ILS approach. The only difference is this time we have a transition for the approach. We've been doing radar vectors up until now, but this time the radar will be out of service, and we'll be doing an ILS approach with a transition. And then after we do the auto land, we'll taxi in and do our after landing shutdown and securing procedure. Here's our flight plan for lesson 5. Again, Boeing Field, we would have been at Bravo 4. We'll be taxiing to runway 32 left. That would be coming out of the Boeing ramp and taxiing down all the way down to the other end of the runway. Fairly decent long taxi. But again, we're not going to do that because we'll be in the whole short position. Route of flight will be Seattle, Victor 23, Battleground, Victor 112, Pendleton, Victor 536 to, I think that's Putnam, maybe, Papa Uniform Whiskey, and then direct Moses Lake. SID will be the Needle 1 departure, destination Moses Lake, Sonic 44 will be our flight number. We'll be in, what can we be in? I think we'll be in pounds. We'll just stay in pounds. We'll have a legacy FMC as well, and we'll be a freighter on the next period, so kind of like we were in the beginning. So 450 zero fuel weight, 155 on the fuel, and 605 on the gross weight, 1,000 pounds. Cost index 100, cruise altitude flight level 190 will be full TO, full climb, flap 10 takeoff. And looks like we're still at NADP 2, which is acceleration height 1,000, engine out 1,000, and flap 5 thrust reduction. Winds are calm, slope 0, the CG 25. So a lot of the same information. Echo will be the ATIS. Winds are calm, 2 statute miles, freezing drizzle, overcast skies at 800 feet. Temperature 1 Celsius, dew point 0, altimeter 2980. And we'll be departing runway 32 left. And that'll be Echo. And then when you get your clearance, which we'll already have in our case, since we'll be in the whole short position, we'll be cleared to Moses Lake via runway 32 left. The Needle 1 departure flight plan route. We're going to skip that climb and maintain 7,000. So he's not going to give us an altitude. And if he doesn't give us an altitude, then the SID, which is the Needle 1, if I can pull that up here, let's see. So you'll see the Needle 1 has a top altitude of 2,100. So we'll amend that clearance to just cleared Moses Lake, 32 left, Needle 1. Flight plan route, expect flight level 190 10 minutes after departure. Seattle departure 126.5, squawk 2346. So we'll have the top altitude of the SID be 2100. And that's just so that we can look at a low altitude level off. Here's what the map looks like on lesson 5 for you Patreon members that have all this paper information or digital information. We're going from Boeing Field to Moses Lake, and you can see that the original route, planned route, goes to Battleground and to Klickitat and to Pendleton and to, I think it's Putnam. It's off the Papa Uniform Whiskey. It's off the screen there. And then to Moses Lake VOR. But then along the way, we modify it to go direct to Pascal, Papa Sierra Charlie, direct Pelly. And then the route is modified even further, where you see number 11, 12, 13, and 14 as we go direct Rubel. And then we're expecting the ILS 32 right with a Rubel transition on this particular lesson. So there's a planned route and then an intermediate change in the route, and then there's another modification of that along the lesson. And then here are the particular items that we're going to be accomplishing. Speed intervention, that'll be shortly after takeoff. And then we'll be taken off the route to intercept a course to Melee. And then we'll be taken off our course to do an airway intercept like we did the last period, lesson 4. Then we'll do a cruise climb. We'll change our cruise speed. We'll do a cruise descent. We'll do holding. We'll have a route modification. We'll go direct to a waypoint. And then we'll do our approach preparations. And of course, we'll talk about the progress page somewhere in there. And again, the approach will be with a transition. And then icing and clouds will be reported at 10,000 feet. So we'll show how we can go to the descent forecast page and put in our nacelle anti-ice altitude in there to affect our top of descent or a vertical deviation indicator. And then we'll descend to 4,000 feet in VNAV, and we'll accomplish the approach, which will encompass a procedure turn. And the radar will be out of service, so we'll have to make a few calls along the way, like report Pelly outbound and report procedure turn outbound and things like that. And then after we land, we'll do our after landing shutdown and securing. Okay, we're on our PowerPoint now for lesson 5 brief. So cold weather operations, since we have icing conditions today, cold weather operations can normally be found in the supplemental procedures under adverse weather. So you'll see here on the supplemental procedures, you have a chapter or section 16, and that's adverse weather. We don't expect pilots to remember everything that's in this section. If they have to refer to it, they can go to the FCOM, and they can go to the supplemental procedures, and they can look up the adverse weather if they need to review it. So generally, this isn't memorized or anything like that. We always have an idea of what icing conditions are. We know that it's 10 Celsius or below, and if there's visible moisture, we've got icing conditions. But all that is more or less spelled out in this section of adverse weather. And sometimes if you can't remember, well, it's been a long taxi and it's been more than 30 minutes and now we have to, clear the engine. How do we do that? I can't remember. Well, I could go to the adverse weather section to do that. If you didn't remember the static run-up. Again, most pilots will know it, but if you didn't know it, you could go to the adverse weather section to check it. So icing conditions will exist anytime the outside air temperature on the ground or the TAT in flight is 10 degrees centigrade or below, and if there's visible moisture present. Visible moisture can consist of clouds, fog with visibility 1 mile or less, and of course the liquid type: rain, snow, sleet, ice. The weather could be clear, but you could have ice, snow, slush, or standing water that's on the ramp, taxiways, or runways, and that would constitute icing conditions as well. For the exterior inspections, generally we pay more attention to all your surfaces, your pitot and static ports, your pack inlets and outlets, flap fairings, because that can be particularly susceptible to moisture getting in there and then freezing. Landing gear, gear doors, fuel tank vents, all these things are more susceptible to possible icing, and so we generally check them during the pre-flight. Certainly upper and lower wing surfaces, APU air inlets, the empennage area. We want to make sure that most precipitation is off those areas, and if it's not, we'll have to have de-icing and go to the de-icing area and de-ice the airplane. Some of the start considerations during cold weather would be that the oil pressure may be slow to rise compared to normal temperatures. The initial oil pressure can be higher than normal and then come down. Some warm-up time may be needed to allow the oil temperature to rise. It may not rise as rapidly as it normally does. The LCD displays can require additional warm-up time if you're coming from a cold-soaked airplane. And the LCD displays may be dim as well. With icing conditions, generally the nacelle anti-ice must be selected on either after all the engines are started or one engine at a time. It's kind of your choice how you do that. If you think the icing conditions are severe enough, then I would do it after each engine start. But generally we do it after all the engines are started. That's generally not that much time to for the engines to be unprotected. But there's always the option to do one engine at a time if the captain chooses to. The auto switches, of course, the toggle switches would be the auto off-on switches. And those switches are generally in the auto position, and so on the ground we have to turn them on because the auto position doesn't work when you're on the ground. It works in the air, and where the nacelle ice will come on automatically if the ice detector senses there's icing conditions in flight, but on the ground that's not applicable. So we'd have to take the auto switches and turn them on the ground. And then when you're airborne, usually after the flaps are up, and you bring the gear handle to off, then you can go up and bring those switches back to auto, from on to auto, and then you will get the automatic turning on when the ice detector senses it. Of course, if you have the on-off switches, then you have to turn the nacelle anti-ice on with the alternate action switch, again, one at a time, or all 4 engines after you're completely started. We want the nacelle anti-ice on during all ground operations when icing conditions exist. It's not required if the temperature is less than -40 Celsius outside air temperature. If the temperature is that cold, nothing's going to stick to the airplane. It's just way too cold for icing to exist. You could still have something in the air called ice crystal icing, but that's a different kind of animal. This is more on the surfaces of the airplane itself. Some of the taxi considerations would be to taxi slower than normal. That's just common sense. If the runway is contaminated, it's got some slush or snow, we're going to taxi slower than normal, proportionate to the conditions. So obviously taxiing through dry snow is going to be different than taxiing through slush. And depending if you're taxiing on icing conditions or some kind of ice, patches of ice, you're going to want to taxi obviously slower, even more slow. We do consider delaying flap extension if we have to taxi through contaminants, because that can throw stuff into the flap fairings. And so you could wait until you reach your hold short position and then extend the flaps when the taxi is completed at the end of the runway. And then those flap fairings are less susceptible to getting any kind of slush or splashing of water onto the flap fairing, which could then freeze. Of course, we don't run the before takeoff checklist if we are going to taxi to the end of the runway with the flaps up. Once we bring the flaps, extend the flaps when you're in the hold short position, then you would run the takeoff checklist. So we wouldn't run that during the taxi in that case. Anytime nacelle anti-ice is required, and that means there's icing conditions, and the temperature is 3 degrees centigrade or less, then you have some engine run-up considerations that you have to maintain. And that would be to check the area behind the airplane is clear, or as clear as you can get it. And then for the GE engines, generally it would be to run the engines up to 60% N1 for 30 seconds every 30 minutes. So if you had a really long taxi and you were, on the ground for more than 30 minutes, we'd have to do a run-up to break ice, off stator vanes and things like that. And by running up the engine to a higher power setting, that's going to create enough vibration to dislodge any ice that may be on stator vanes. For the Pratt & Whitney engines, it would be 50% N1 for 1 second every 15 minutes. So again, if you were to taxi out quickly, this wouldn't apply, but if you were at Kennedy Airport, for example, and you're number 40 for takeoff, and it's going to take a while before you're airborne. Anybody that's been to Kennedy knows that it can take, easily 45 minutes to over an hour to get airborne when you've got a winter storm that's happening. And I've been there many times where you sit there, wait. And in those situations, you may have to do a run-up, after the 30 minutes for the GE, which we are today. And then, of course, in addition to that, you have to do a static engine run-up, and that's what we're going to be doing because we'll be on the runway. So again, when nacelle anti-ice is required, again, that means when you have icing conditions, 10 centigrade or less with visible moisture, and the outside air temperature is 3 centigrade or less, then you have to do a static run-up prior to takeoff. And you'd have to let the tower know that you're going to be in position to do a run-up prior to takeoff so they can allow that extra time. And generally, they don't have a problem with that. The GE engines would be 60% N1 for 30 seconds. And then after 30 seconds, if you're clear for takeoff, you could increase the power to 70% N1, stabilize, and then push toga and go. The Pratt, it would be 50% N1, and that would just no time requirement, just momentarily stable, and then you continue for takeoff with the Pratts. So you see the GEs have a little more criticality to them in terms of time. The Pratt's not quite as much. The wing anti-ice will operate, or the nacelle anti-ice will operate when ice is detected if you have the auto position. So if you have the auto position on both nacelle and wing anti-ice, then if ice is detected, they will go ahead and turn on automatically. If you're manual, then you have to turn it on and off. There is no auto position. There's just the off position and an on position. And so you have to manually turn on and off based on what you see. And what you see in terms of temperature and what you see in terms of ice buildup on the wipers or the windscreen or the center post, or there's things you can use. You can't see the wing, so it's hard to judge what's on the wing without going back into the cabin and looking. But from the flight deck, you can see the wing, but you got to kind of crane your head all the way around. And you can see the wingtip, basically, not the whole wing. Wing anti-ice can be used as a de-icer or anti-icer. As a de-icer, it would mean that you could wait for ice accumulation that's already on the wing and then turn it on, and that would then clear that ice from the wing. An anti-icer would be you turn it on prior to getting into the icing conditions, and then it would prevent any kind of ice from forming, but you're turning it on basically prior to getting into icing conditions. It's in this airplane, again, it can be used as a de-icer or an anti-icer, but it's more effective as a de-icer, they say, which is more surprising actually. So they'd rather have some ice accumulation there before you turn it on. Of course, the wing anti-ice, if it's in the auto position, it's going to turn on when it turns on. So it takes care of that for us. These airplanes, usually you're not in icing conditions for very long. You're given climbs through clouds. The rate of climb is such that you can get above most of the critical icing. You're not in it for long generally. These wings don't pick up a lot of ice. The tail doesn't pick up a lot of ice. There's smaller airplanes where ice is more critical. Some of the regionals that I used to fly, when I used to fly the shorts, sometimes you got caught at 9,000 feet in the tops of the clouds, and you would just be picking up ice like crazy and shedding it. You'd hear it slam against the fuselage. These airplanes, you're pretty much up and through it in no time. And even if you were stuck somewhere, you're not going to pick up ice like you would in other airplanes. So generally, we can use it as a de-icer, especially if you have the on and off switch. If you have the auto switch, it's going to take care of it. It turns on when it needs to. One place where wing anti-ice is not effective is if the leading edge flaps are extended, then all the air is just going overboard. It's just being pissed overboard. So until the leading edge flaps are retracted, then you could get the heat to the wing, but otherwise it's just going to be dumping overboard. We don't want to use nacelle anti-ice or wing anti-ice with temperatures above 10 Celsius. That's because, again, structurally it could start to do some damage if it's warm and you're trying to use anti-ice. And so, again, if you have the manual switches, you'd be turning them off. If you're climbing and maybe there's an inversion and the temperature gets above 10 Celsius, then we want to turn it off. You will get an ICAS message that says anti-ice if you're at 12 degrees Celsius and you still have the nacelle anti-ice on. Then you're going to get a message basically telling you it's too warm to be using nacelle anti-ice or wing anti-ice. There's other considerations that are talked about. And by the way, all these things are talked about in the adverse weather section. So if you're interested, go read that section. You have cold temperature altitude correction tables for altimeter errors. So generally, it's got to be pretty cold, minus 30 Celsius or greater. Then we might have to make some corrections for altimeter since it's so cold. Those graphs are in that section, in that adverse weather section. After landing, we could again do the same things we did for takeoff, and that would be delay flap retraction. If we needed to on the way in. Again, and that way, if there's any question about whether there's any freezing in the flap fairing critical areas, that could freeze up, you could leave the flaps retracted and then have maintenance, check prior to you retracting them. But generally, you'd probably want to tell ATC that because it used to be when the flaps were extended and you taxied in, that would be a hijacking. I don't know if that still is or not, but we'd have to kind of warn ATC that we're leaving the flaps extended to have our maintenance check as we taxi in. And that's if you only suspected that there might be maybe you had some icing on the approach that was pretty bad and you want maintenance to check the fairings before you go ahead and retract the flap. Again, on the way in, you have to use nacelle anti-ice if the icing conditions are there and you're, again, 3 degrees Celsius or less. or 10 degrees Celsius or less with the visible moisture, you're going to turn on the nacelle anti-ice. And again, you'd have to, even if you have the auto, you have to go to the on position when you're on the ground. Taxi speed, same thing. We have to take into account that taxi speeds are going to be slower. Engine run-up considerations, you got the same ones on the way in that you had on the way out, although it's probably not going to take you more than 30 minutes to, or 15 minutes to taxi in. But if it did, you'd have to do the run-ups that are required on the way in as well as on the way out. And then when you get to the gate, secure procedures, if the airplane was going to stay there for a while, they have recommendations to close the outflow valves, don't set the parking brake, be chalked, so there's not any possibility of it freezing. The airplane should be chalked, and then there could be covers put on, but that's up to maintenance and the ramp personnel to decide what to do there. But there's some things we can do, like release the parking brake and be chalked and close the outflow valves. We will have this little low altitude level off at 2,100 feet. Low altitude level offs in this airplane is not a big deal if you're using VNAV for takeoff. Other airplanes, this could be more of a factor, but this airplane is not. If you do capture the altitude prior to the flap retraction altitude for acceleration, then the airplane will start accelerating at that time. So depending on your climb rate, if we were to capture prior to the 1,000 feet, let's say, then the airplane will start accelerating at that point that it captures the low altitude. It's not going to use what's on the takeoff reference page for acceleration if the altitude's captured early. If for some reason you were to forget a pitch mode on takeoff, which is not normally done, but it could be, then when you capture the altitude, the auto throttle would not be in the speed mode at altitude capture, and then you'd have to select the speed mode manually to prevent the speed from running away. We're going to have a speed restriction as we take off. At some point, ATC will say to maintain a speed of 230 knots till further advised. And in order to do that, again, there's two ways to do that. One would be through the CDU, and the other way would be through the mode control panel. And taking off and maneuvering and being at a lower altitude, the more prudent way to do it would be through the mode control panel, because that's heads up. The CDU would be more heads down, and you're in the terminal area, and you want to be heads out in the terminal area when you're at a lower altitude. So generally, we can use speed intervention to do that, to maintain that speed of 230. When you're in VNAV, the indicated airspeed Mach window is blank. The FMC is controlling the speed, and the speed in this case is controlled to 250 knots. It's an active 250 knot climb, 250 below 10,000. The weight is such that it allows 250 knots and not higher. And then, of course, to go ahead and maintain a speed after takeoff at a lower altitude, we can simply open the window by pushing the selector. That opens the indicated airspeed Mach window. Anytime the window's open and you're in VNAV, then that indicates that you're in speed intervention. You're controlling the speed instead of the computer controlling the speed. So at that point, you can go ahead and bug down the speed to 230 knots. And then you can hold the flap setting where it is. You wouldn't want to retract the flaps fully at that point, since you're not going to have enough maneuvering margin. So probably at 230 knots, you're probably going to have to stay at flaps 1 until we get the OK to resume normal speed and accelerate. And then we would retract the flaps up as the airspeed's accelerating above the up bug. Okay, so again, you see the title of the VNAV page right here, if you see my pointer. It says active MCP speed climb. So that tells you what you're controlling to. Remember, before it said active 250 knot climb, and we were controlling the 250 and the window is blank. But once you open the window, this title of the page changes to active MCP speed climb. So the title always tells you what you're controlling to. So it's good to kind of look at this VNAV climb page and look at the title, because that tells you what speed you're controlling to. So in this case, all we need to do is bug the speed down to 230, like you see we did here. And ignore what's on the ND here. This is actually the, this is not the needle 1 departure. This is what was called a quiet 1 departure. And I had to create that by creating waypoints here. So this is an old SID that's not applicable anymore. So we'll be coming off of 3-1 left and going direct to Seattle. So kind of ignore what's on here. It's not applicable to the lesson that we're going to be doing. And then when we need to resume normal speed, it's very easy to do that. Just reach up, push the selector, and then the window will go blank. When the window goes blank, the title of the VNAV page changes to active 250 knot climb. And we're controlling back to the 250 below 10,000, window blank. And now, of course, the airspeed will be allowed to increase. And as we get to the up bug, with the arrow accelerating, then once we're at the beyond the up bug, arrow's accelerating, indicating we are accelerating, then we'll go ahead and go flaps up. In this case, I wouldn't retract the flaps yet, because I don't see an acceleration arrow. And maybe for some reason we're bogged down here at the up bug. But I want to see at least the up bug or higher with an acceleration arrow, with that arrow going up. And then when I see that, I can go ahead and retract the flaps then at that point. So we'll do that little speed restriction on takeoff exercise. As we get a little further along, we'll have a clearance to turn right to a heading of 210. And we'll fly heading 210, heading select. Airplane will turn the shortest direction to 210, which is a right turn. And then the clearance is going to be to intercept the 150 course to Malay and track it inbound. And Malay is a waypoint, so it would not be given to you as a radial. It would be given to you as a course, because it's a waypoint, not a nav aid. You'll notice on the legs page here, Malay is the second waypoint. O'Neill's is the active waypoint. We want to make Malay the active waypoint, so we're going to line select L2 here to bring Malay to the scratch pad. And then we're going to line select it up to L1 to make it the active waypoint. And when we do that, it would look like this. Malay would be the active waypoint. But you'll notice on the ND that it's going present position direct to Malay. And that's not necessarily what I want. I don't want to go direct to Malay. I want to intercept the 150 course to Malay. So in that case, I'm going to use the intercept course line, which is the R6 position, to put that course in. And in this case, it's the course into Malay is 150. This intercept course is always an intercept course to, never an intercept course from. So you can see that there. It'd be nice if they put a little to there, intercept course to, because it's always a to course and never a from course. So if you want to intercept the 150 course, we simply type out 150 on the scratch pad, and then we can line select that into the intercept course line. Now, of course, if this was a VOR for some reason, let's say Malay was, maybe it was a Mike Alpha Lima VOR, let's say, and they gave us a clearance to intercept the 330 radial of Malay and track it inbound. Well, they'd be giving it to us in the form of a radial. And in that case, radials are always from at nav aids. And we want to go to the station, so we'd have to take the reciprocal of that 330, which would be 150. And then we put the 150 course into the intercept course line. And that would be a 150 into Mike Alpha Lima, which, let's say it's a VOR. that would be the 330 radial coming out of Mike Alpha Lima. It's the 330 out, it's the 150 in. But in this case, it's a waypoint, so he's going to give it to us in the form of a 150 course to Malay. So all we need to do is type out 150, put it in the intercept course line. And when you do, that intercept course is going to go big, like you see here. And then when you do that, the 150 course will go above Malay as well. So not only does it go big here, but you see this change to 150. And then, of course, that direct to Malay dashed white line will now become a dashed white line that goes out for 699 nautical miles, basically to infinity as far as we're concerned, because you can select any range and it's still going to be there. And then you can execute that and, of course, ask for confirmation. How's that look? There's the 150 into Malay. Looks good, execute. And then when you execute, the dashed white line will go to solid magenta, and you'd have that 150 course into Malay, 699 nautical mile line here. And then we can go ahead and arm LNAV would be the next step. Go ahead and arm LNAV. LNAV will arm in white under your roll mode of heading select. And then, of course, the airplane will continue to track toward the course. And when you get within approximately 2.5 nautical miles, it'll capture. And then LNAV will go green, green detention box around there for 10 seconds. And the airplane will turn into Malay on that 150 course inbound. And again, as we talked about before, that intercept will be dependent upon your speed, your intercept angle, and your closure rate. So if you're going in here at a high speed and you're going in here at, let's say, a 90-degree intercept, well, it may capture at 6 miles out. If you're coming into it on a 20-degree angle and you're at a slower speed, it may intercept at 1.5 miles out. So the way they state it is approximately 2.5 nautical miles, and approximately means approximately. So it's not like at 2.5 miles it's going to capture. It depends on that intercept angle, closure rate, and speed. So in this case, it probably, if you're going the way we're going, I bet this probably intercepts around 3.5 miles or something like that. 3 to 3.5, just eyeballing it from the intercept angle and the speed we're probably going to be going at. It's probably going to capture a little more than 2.5 miles, maybe 3.2 or something like that. Would be my guess. Then after that's complete, when we get to Rourke, we're going to be given a heading of 120, and we'll turn to 120, departing from Rourke. And then we'll, or I may do it a little earlier than this. I may do it out here somewhere. And then the clearance is going to be on a heading of 120, intercept Victor 112 to Klickitat on course. So this would be an airway intercept like we talked about last week. Now, there's one of two ways you could do this. There's the easier way, and then there's the harder way. They're demonstrating the harder way here, or I'm demonstrating because I made up these slides long time ago. The one way would be, well, let me go over this way first. I'll go over, because this is the way we're going to do it, but we're going to do it both ways. I'm just not going to execute it right away. But remember, we learned that you could put the airway, you could go to the route page and put the airway into the route page. And remember, you'd have to go to page 2, because page 1 is just the origin, the destination, all that stuff. You go to page 2, now you'd have your airway. And since we're talking airway, this is where we want to go. However, notice that Victor 112 is part of my route already. So really, I don't have to do this method. I could just go to the legs page and look at this and say, well, there's Battleground, there's Gimme. I'm going to intercept between Battleground and Gimme, kind of in the middle here. So all I would have to do is go to the legs page and bring gimme to the scratch pad, gimme to the top, and then that course from battleground to gimme would be in the intercept course line, but it would be small font. But because that's the previous inbound course to gimme is from battleground to gimme. So all I would need to do is push that intercept course line, make that big, and then I'd get that 699 nautical mile line into gimme along that airway, which would be gimme through battleground and out this way. So that'd be the easiest way to do it. But what they're demonstrating here is they want to demonstrate the intercepting using the airway, but you wouldn't have to do this actually, because Victor 112 is already part of our route. And that's the clearance, intercept Victor 112 to Klickitat. So we look here and say, oh, Victor 112, oh, that's just from battleground to Pendleton. Okay, let me just go to the legs page and I'll extend the line to gimme. That's all you would have to do. But they're kind of doing it the hard way here. So we're going to demonstrate both methods here for the sake of the exercise. And this is the harder way to do it. And you're still going to end up having to do what we did first here anyway. So let's say we just put in the airway, Victor 112, and put it to the top. Now let's put it right to the top. And then it would say Victor 112 to where? Well, we want to go Victor 112 to Pendleton, because that's the point that we want to go to. Or I'm sorry, Klickitat. Victor 112 to Klickitat. So we could put that in there. Victor 112 to Lima, because that was the clearance. So Victor 112 to Lima Tango Juliet. And we could put that in there. And then remember, we said last week that the computer will think about it and think about where you are and where the airway is and pick a starting point of the airway based on your position. So if we put Klickitat, Lima Tango Juliet, into one right, then you'll notice it comes up with Pitter, Victor 112. And it goes to Pendleton because it just skips Klickitat because it knows you're going to Pendleton, and Victor 112 does go all the way to Pendleton. So it kind of ignores the Klickitat and says, well, you're already going to Pendleton anyway, so this is the whole segment, Victor 112 to Pendleton. But notice Pitter is, again, it kind of looks at the waypoint of where you are. And in this case, it built this segment. It probably didn't pick battleground because you're already past the beam battleground. Because battleground is closer to the airplane position to create that airway, but it picked this point, Pitter, down here. So why did it do that? Well, probably because we've passed that beam position of battleground. Otherwise, it would have picked battleground because that's closer. It's closer, but we passed it here. So it picks this instead, Pitter. And then we could execute that. And we did. Okay, so now Pitter's the active waypoint. Well, I don't want that. And I don't want battleground to be the active waypoint because I'm past battleground. But you can see where I'm going to intercept here. On a 120 heading, I'm going to intercept between battleground and gimme. So what am I going to do? The same thing we talked about initially, which was I'm just going to go to the legs page. And now I have to do the same thing we just talked about anyway. I have to bring gimme down, put gimme to the top, and now it's going to go direct gimme. But I don't want direct gimme, but I do want this course. That 07 course is the previous inbound course to gimme from battleground, Bravo Tango Golf, to gimme is 072. But it's not active because it's in small font. It puts it in there, but it's not active. We have to make it big and push the caret, and that'll make it big. So when you push the caret, the 072 will go big. 072 will go on top of gimme up here. And then you'll notice we have the white dashed line going into gimme on the airway through battleground. And again, that's that 699 nautical mile line. As far as we're concerned, it's infinity because we only go up to 640 range. And then we can execute that. And we'd say, there's Victor 112 to Klickitat, or to Pendleton actually, all the way through. And how does that look to you? Now, that's why I see, again, could we have done just gimme to the bottom, gimme to the top, put the course in? Yeah, because we already had Victor 112 in there. But we did it the long way here just because we want to do the airway intercept method. But you can see that you could have just brought gimme down, gimme to the top, push this intercept course, got that 072 in the white dashed line. So we'll execute that. And then gimme becomes the active waypoint. The line goes through battleground, battleground goes away, and it's that 699 nautical mile line. Then we can arm LNAV, and again, same thing, when we get within approximately 2.5 nautical miles, we'll intercept to go to gimme. So we'll show both ways again when we do this in the airplane. Normally airway intercepts, you're normally going to get one on a check ride. Cruise climb, once we get to our cruise altitude 190, we'll be cleared up to flight level 210. And so we spin the window up to 210, and then we push the selector. When you push the selector, that's automatically going to change the cruise altitude on your cruise page to 210, and this title will change from active econ cruise to active econ cruise climb. And so it'll do a cruise climb at cruise airspeed up to the new cruise altitude. So you'll see that we put it in, we push it. There is no execute on this. When you push it, you're going to get this. That changes to 210. The title of the page changes to active econ cruise climb, because we're telling the system basically climb to 210. We're changing our cruise altitude, change it for me. And so it'll do a cruise climb at cruise airspeed up to that 210. And that would be a modification to a higher cruise altitude. Then we're going to get a request to slow to 290 knots. And again, we could do it one of two ways again, through the mode control panel by speed intervention, or through the MCP if we typed out 290 and put it in there. But in this case, we're just reaching up. The pilot flying is just reaching up, opening the window, bringing the speed back to 290. And again, notice the title of the page changes from active econ cruise to active MCP speed cruise, meaning you're controlling through the mode control panel. And that's called speed intervention. And when ATC says resume normal speed, all we have to do is push the selector again. Window blanks, meaning the FMC is controlling the speed. And now notice the page changes back to active econ cruise. And we go back to our cruise speed automatically. We're also going to get a cruise descent, so we can look at that. So he'll descend us back to flight level 190. We'll spin the window down to 190, and we'll push the selector. When you push the selector, that's automatically going to change the cruise altitude from 210 down to flight level 190 and do a cruise descent at cruise airspeed. And the title of the page would change from active econ cruise to active econ cruise descent. So when you push that, you're going to see this, active econ cruise descent. Again, remember we said the title of the page tells you what you're controlling to. And this is, it's good to always get in the habit of looking at the title of that page. Because again, the window's blank. You can't tell much from this except the FMC's controlling the speed. Well, what speed is it controlling to? Well, right here, active econ cruise descent. And it's going to descend at this speed down to this altitude, 190. Then we're going to do a holding pattern. We'll get a hold at Klickitat. And we'll do a couple of these. I mean, the lesson just says to hold at Klickitat on your inbound course with right turns. Well, that means all we would have to do is push the hold key. When you push the hold key, you'll get the legs page with, again, it's a normal legs page. Nothing changes here. But what you have here is hold at boxes or PPAWs. Now, we talked about PPAWs last week. That's what we did, is we pushed that, executed, and it created a lat long and held at your present position with right turns. But if you don't want to hold present position, the boxes indicate where do you want to hold. It's asking us. That's a mandatory entry whenever you see boxes. So we want to hold a Klickitat. So we're going to bring down Lima Tango Golf, or Lima Tango Juliet, into the scratch pad and into the boxes. They've already done that here. And then you'll notice it'll create a holding pattern along our inbound course with right turns, standard holding. It always defaults to our inbound course with standard holding, which is right turns. Now, if we don't want that, we can change it. But in this case, that's what we're going to want. But we're going to do this with kind of showing several exercises here. So you'll notice whenever you get the default of the inbound course with right turns, the quadrant radial line stays dashes because we're not using it. We're just using an inbound course, standard holding. We're above 14,000, so a minute and a half legs inbound. And if that's what we wanted, we'd execute that. But let's say they said hold northeast of Klickitat. Hold northeast of Klickitat. On the 030 radial, left turns 10-mile legs. They give us a clearance like that. Well, that's when you can use the quadrant radial line because he gave us the clearance in terms of a VOR with a radial. He said hold northeast on the 030 radial, left turns 10-mile legs. Well, because he said northeast on the 030 radial, I heard radial and I know it's a VOR, I can put the radial in. So I could type out here, if we wanted to change this, I could type out 030 in the scratch pad and line select it to left. And then it would take that radial and it would say 030, and then it looks at the number and says, okay, 030, what quadrant is that in? It's northeast. So it would put it NE automatically. So you don't need to tell it northeast or south or west, or it just looks at the number and says, based on that number, what quadrant is it in? In fact, if you were to put west/180 in there, it would change it to south. It knows 180 is south and not west. So if you put something in that's wrong, it'll change it for you because it's just looking at the number. It doesn't care about the what you're putting in. So you could put the radial in 030, line selected here to left. It'll say 030 and it'll say NE/030. And then the inbound course will be the reciprocal, which would be 210, and then we'd have to change this to left turns, and we'd have to change this to 10-mile legs, just like the clearance said. So we're going to do a couple of these just to look at it. But the lesson is basically just to hold at your Klickitat, standard holding right turns. In which case you can see we've executed it. Klickitat is still the active waypoint. We crossed it, we enter the hold, and again the best speed, if you're in VNAV and the window's blank, the airplane's going to slow down to your best holding speed, 244. And like we discussed, that may be too slow. You can always change that. You can always speed intervene, bump it up if it's too slow because you're in turbulence and you're turning in a holding pattern. That's the most efficient speed, but that doesn't necessarily mean that's what we want based on, the conditions. In this case, when you enter the hold, you'll notice that there's an exit hold prompt, and that's how we get out of the hold. We get out of the hold by exiting the hold. By pushing exit hold, it'll say exit armed, executing it, and then the airplane, in this case, would just shorten the holding pattern up completely because you're less than 2/3 of the way out, and the holding pattern would then shorten up to basically just a 360 and come back to Klickitat, leave Klickitat, and go to the next waypoint, whatever that is, Pendleton or whatever. You'll also notice there's a next hold here. If you have to create another hold somewhere, you could push the next hold function key here, and it would then change to the legs page with hold at boxes and P-pause again. But in order to exit the hold, we use the exit hold prompt here at 6 right. And it says after 2 turns, exit the hold. And it looks like we have an amended routing. And so we'll hold in there for a while, and then the amended routing is going to be after Klickitat, direct Pascal, direct Pelly. That's the same one we got last time, actually. So we'll put that in. We're holding at Klickitat, and then we'll put in after Klickitat, direct Pascal, Papa Sierra Charlie, direct Pelly. That creates a discontinuity again. And then there's going to be all these waypoints that go from OGPE to ECODE to Alpha Lima Whiskey to all this stuff that's going to be the unwanted segment. We're not going to, so we have to get rid of this because he's just saying go direct here to here. But what about all this stuff that's still there? It doesn't necessarily disappear. So we can go ahead and execute that. And when you do, again, if we're still holding here, it looks like we are. That discontinuity is here, and now we want to remove all this other stuff. Remember, we said the easiest way to do that is go to the last page, and you'll see that Moses Lake is the last waypoint as part of that grouping, part of this grouping right here. Take that last waypoint, bring it to the scratch pad, go to the previous page, and then bring Moses Lake into the boxes. And then it's very easy then. That bypasses everything except Moses Lake. And then all we need to do is delete Moses Lake. Yep, let me go back here. And they didn't do that here. It looks like they didn't do that. But normally we'd then go delete. Delete would be in the scratch pad. Delete Moses Lake. And then you'd have, after, it looks like we exited right here. Notice the waypoint went white. Pascal went magenta, so we had exited the hold here. And now it's on its way to Papa Sierra Charlie. So after that, it's direct Pelly, direct Moses Lake. But we don't want Moses Lake, because all he said was, after click at that, direct Pascal, direct Pelly. So we need to get rid of Moses Lake. So we push delete. Delete comes in the scratch pad, and then delete Moses Lake, execute, and then you get rid of Moses Lake. And so we bypassed all those waypoints and just got rid of one waypoint by deleting. Again, like we talked about, could you delete all the way? Yeah, you could, but it's going to be, it's like 10 more keystrokes than you need to do. Then as we're on our way to Pascal, we're going to get a clearance to go direct to Ruble and expect the ILS 32 right approach with the Ruble transition. So first thing we got was direct Ruble. So we'll put in direct Ruble, type out Ruble in the scratch pad, bring it to the top of page 1. It's the active waypoint, execute it. How's that look? Looks good. There's direct Ruble. Looks good. Execute. LNAV's available. LNAV's engaged. We go through that routine just to make sure we're both on the same page. And again, now you've got some unwanted segment again. You've got Pascal, Pelly. They left Moses Lake in here. I would have got rid of that because that's not part of the clearance here. Or that wasn't part of the clearance. It was just go Pascal to Pelly. So we're going direct Ruble. And then he's going to say, we'll expect the ILS 32 right with a Ruble transition. So we'll go to the departure arrival key, push that. Again, the logic is such that if you're more than half the distance to your destination, or 400 miles, whichever comes first, then it's going to give us the Moses Lake arrival page. If we were less than 400 miles, or half the distance, whichever comes first, it would give us the arrival page back to Boeing Field. Because it kind of knows what it thinks it knows what you want to look at. So if you just took off from Boeing Field and you're like 100 miles away, and you need to return and you push Dep R, you're going to get Boeing Field arrivals because it knows you're not more than halfway yet. And that's what you'd want if you have to return to Boeing Field. But in this case, if we're more than 400 miles or half the distance, whichever comes first, and you push the Dep R key, you're going to get the Moses Lake arrivals, and that's what we want. Now, if this wasn't what we wanted, remember you always have an index prompt down here. Right now it's not there because we selected the ILS and there's an erase prompt there. But if you hadn't selected the ILS, this would say index. And then that allows you to get to the Dep R index if this wasn't what you wanted. But in our case, this is what we want. So we have the Moses Lake arrival page, ILS 32 right, we select that. It says selected. It's not active yet because you haven't executed it. And then we want the transitions. In this case, we do want a transition. He said expect the 3-2 right approach with a Ruble transition. These are in alphabetical order, so you can see this is page 1. We go to page 2, go to next page. And that would be right here, because you got page, again, 1 of 2, and there's more than these 4 transitions. And ruble comes after plus, so we're going to go to the next page. And there's ruble. There's quint, ruble, wipes. We want ruble. So we select ruble. And now we have the ILS 32 right, ruble transition. They're both selected. No stars coming in. And then we can execute that. When you execute that, this will then say active. Didn't show that, but it would say active once you execute it. And by doing that, you're going to get ruble going to Pelly, a procedure turn from Pelly outbound back to Pelly to the runway. So by selecting that transition, you get this segment right here, which is basically a course reversal from ruble to Pelly, course reversal, and back for the ILS. So that's all going to be put in there as part of the selecting that transition. Now we'll get a clearance, we'll brief the approach obviously, and get a clearance to descend and maintain 4,000. And if we don't set 4,000 in the altitude window, as you approach your top of descent point, and you're within about 3 minutes of the top of descent point, and you haven't set a lower altitude, you'll get a message in the scratch pad saying reset MCP altitude. It's just a warning that, hey, you haven't set anything lower, and based on the profile that I've created for you, me the computer, I've created this profile for you, and if you want to start down to follow that profile, the top descent is in front of you and we're approaching it. So reset your MCP altitude window, the computer's telling you. Now, of course, if we haven't gotten a descent yet, we could request one from ATC. We don't have to start down at the top of descent. If ATC can't let us down, then we may have to wait for a little bit and then do more of an expedited descent. But generally, we could request, if we were at this position and he hadn't cleared us down, we could request a lower altitude from the center or whoever we're talking to. But this shows up anytime you're approaching the top of descent, you're about 3 minutes from it, and you haven't reset your MCP altitude window, you get this message. It's a high priority FMC message, so you get the message, you get a message light, and you'll get an ICAS message saying FMC message, or whatever it says. But I think this is a high priority FMC message. There's high priority messages in the scratch pad, and there's low priority messages. The low priority would not give you the ICAS message on the alert screen. The high priority ones will. And you get this message light, but you also get an ICAS message telling you to look here. Look at the scratch pad. There's something in there that you need to know about. That's more of a high priority FMC message. And I think this one is high. So we're going to go ahead and set 4,000 in there. And then when the airplane reaches the top of descent point, it's going to automatically, then thrust is going to go to idle. And it will then be on the VNAV path into the ILS 32 right with the ruble transition, taking into account all the constraints all the way down to your end of descent point. Now, in this case, one of two things. I'll probably do it both ways. We could be out here somewhere prior to the top of descent point, and maybe we get a report from ATC that, expect moderate rime icing and clouds from 10,000 feet to the surface. Well, that would be an indication that if I'm expecting a nacelle anti-ice to be turned on, or I'm going to turn it on, one of the two, I can go to the descent forecast page to put the altitude that I'm expecting the anti-ice to be put on, or me to put it on, and I can put that in, and that will have the effect of moving this top of descent point back a little bit. So you'll see here that they say, here again, the clearance is going to be, or they're going to tell us, light to moderate rime icing and clouds reported from 10,000 feet. So we can go to our VNAV function key, push that. We're on the cruise page. We want to get to the descent page. Well, the descent page is page 3. There's 3 pages of the cruise pages. There's the climb, cruise, and descent. 1, 2, and 3. So in the case that we want the descent page, we're going to go to next page, and then that will take us to the descent page. It's not active yet, but it's inactive because we don't see active next to it. But on that page, we have a forecast tool here, and the caret means push it if you want to get it. So we're going to push the forecast, and then that will give us the ability to put in up to 4 altitudes and 4 winds in order to more accurately define our top of descent point or our descent profile. But there's also a thermal anti-ice on altitude here. And in our case, since he told us this, we're going to put in 10,000. So if you put in 10,000, it's going to have the effect of moving the top of descent point back. Or in this case, we've already passed the top of descent point, and now we're putting this in. And what that does is the vertical deviation indicator will disappear while it's calculating this altitude. Because again, remember, the approach idle setting is going to be bumped up when you put on the cell anti-ice. And because of that, it's going to take longer to get down. And because of that, it's going to calculate that, okay, you're above the path now. Because we're expecting to turn this on at 10,000 feet, and now we're going to be high in the path. So we may have to help it here with some speed brakes in order to get back on the path. Or increase the speed if we can. Depending on where we are here. We're still above 10,000, so we could increase the speed if we wanted to try to increase the rate of descent to get back on here. Or use speed brakes. So this is showing the vertical deviation path adjustment because we put this in. And I don't think there's an execute light when you do this. It's just you put it in, and it has the effect of recalculating the path. And there's no execute light with this. And now you'll see we've taken whatever measures we need to. It looks like maybe use speed brakes to get back on the path. And the path will show, again, it will recapture the path. By the way, when it does this, it's going to go into VNAV speed. It's going to come out of the path because now you're showing high on the path, and this will change from VNAV path to VNAV speed, indicating that you're controlling to a speed now and you're not on the path. So we're going to have to do something to get back on the path. And in our case, let's say we use speed brakes. And then when you get back on the path, you'll see this change to VNAV path as we recapture the path. And then we're back on the segment here to continue down. And of course, we said last week these are our deceleration circles. The first one is where you'll be right around 11,500, something like that, below 12,000. And you'll start to slow from your econ descent speed, which is a target speed. Remember, this isn't if you're on the path, this speed is allowed to vary, go up or go down. If it goes down too far, the auto throttle will engage. If it goes up too far, you'll get a drag required message, and you can use speed brakes or speed to get back on the path. But once you reach 10,000 feet, or actually below 12,000 feet, right around 11,500, something like that, it'll go ahead and bring the bug and slew it down to 240. And 240 is the speed that VNAV provides for us. It gives us a 10-knot buffer in case there's an unforecast tailwind that exists that the computer hasn't taken into account. And again, if let's say you put in the winds for the descent and that thermal anti-ice on altitude, it all helps to refine the path. And a lot of this is automated, so you can request it from your dispatch. They send it, they uplink it, and you just select it, and all that's put in for you. So it can very accurately define the path, even in the descent. That's not to say the speed won't increase. It still could decrease, because there's, again, there's unforecast headwinds or tailwinds that you can run into, that weren't part of the forecast and part of the accuracy. The second circle is where you're going to get to 240 knots at 10,000 feet. So you can see we're right now at 10,880 feet, descending on the path. We started to slow down. At the second circle, I can expect to be at 240 and just about at 10,000, ready to continue the descent to 4,000 at 240 knots. And here's the second circle. You can see we're at 240, descending through 10,000 on our way to 4,000. That's the end of deceleration. So they don't label these. Most of these little circles they do label. They'll say TD, top of descent, ED, end of descent, SC, step climb. You'll see most of these are labeled, but these two are not. They're just your deceleration circles. They come one after the other, so you know they're part of the deceleration process. Then we're going to be coming in here to from Rubel, and on the approach, when you look at the chart, Rubel to Pelly is 4,000 feet, and then Pelly outbound I think is 3,300 feet, and then 2,800 feet back into Pelly, and then in for the ILS. So as we come into this transition from Rubel to Pelly, we'll be at 4,000 feet. We're going to want to start slowing down to make this turn. We don't want to come screaming in here at 250 knots. So we want to slow down to about 200 knots at flaps 5 to be at going Pelly outbound. So you'll see here we've gone to flaps 5, flaps 1, and then flaps 5, slowed to flaps 5, and again, it doesn't have to be 182 knots. We could be at 200 knots here and to be fine. Depends what speed you want to hold here. And at this point, we'll cross Pelly and then start from Pelly. We go procedure turn outbound. And yeah, this is changed. This would actually be probably 3,300 here. We'll see when we do this in the virtual simulator. This is 39. I think this is old. So you'll see some different altitudes here. And then when your procedure turn outbound, generally at some point maybe starting to turn back, we're going to go to flaps 10. And then as we come procedure turn inbound, we would be, you can see here we're in LNAV right now. Notice we're in LNAV. We're coming around the procedure turn. It may not be right on the line. It's still in protected airspace. So you might see it like you see it here, and it's not going to be necessarily right on the magenta line. But it's still in protected airspace as it does its thing here to go around. And you'll notice, let's say we're clear for the approach, and so we go to flaps 10. We're approaching inbound. As you come inbound, the one thing that's not a good practice is to go from LNAV to the localizer mode directly. Normally, as we come around here, we'll go into heading select to capture the localizer, bring the heading to an intercept, and then intercept from heading select to localizer. The reason for that is that in some cases, again, this is maybe a thing of the past, and maybe it's not as much a factor anymore, but I think we still say it, and I think a lot of airlines say it, is that if you're in LNAV, they don't want you going from LNAV to localizer directly. They want you going to heading select, just in case there's some kind of map shift or anything. And again, that would be more of a factor if we didn't have GPS. If we had DME, this map could be off. And if you stay in LNAV might parallel the localizer but not capture it. That can happen. But with GPS, probably not. So I think it's more of a moot point, I think, nowadays. But I think it's still a practice that people do, is to go to heading select as you complete the turn, and then and then intercept the localizer from heading select, and not from LNAV to loc, but from heading select to loc. And again, if you could arm the at this point. At this point, we probably would just arm the localizer because I don't see a glide slope here, which we probably should see at this point. Maybe we're a little too far out. But we'd arm the localizer. They've armed the approach. Glide slope's armed. I don't see a glide slope here. So if it were me and I don't see a glide slope here, I'd arm the approach, but not the. I would arm the localizer, but not the approach, until I see a glide slope. Oh yeah, no, it's here. Sorry, I can't see it. It's right there. It's a diamond. It's just not filled in. I didn't see it here. There is a glide slope. So in this case, if you show the proper displacement, which it is, the glide slope is above us. We're making our turn inbound. We could arm the approach. You don't have to go. Some airlines will require you to go loc and not approach. We're okay with going to approach directly if you show proper displacement with the localizer and the glide slope. So in this case, we are showing proper displacement, and so we could arm the approach, and that's what they've done here. I didn't see, this is so dim, I didn't see it. And then, of course, we do the regular things here. Glide slope alive, gear down flaps 20, arm the speed brakes, flaps 30, set speed, set the missed approach altitude, which in our case is going to be 4,000 feet. And then we go on in for the ILS approach to our runway 32 right, land out of that, taxi off, and do our after landing procedure. And that's it for the briefing for FTD number 5. So next week we'll fly that. And then after that we start to get into number 6, which then gets into non-normals and starts to get the period starts to get a little busier. Again, as we said early on, this is a matter of really seeing where the students are after lesson 5. And if there's any hiccups in their progress, this is where you want to repeat periods so they can get up to speed on the basics, meaning flight deck prep, flow patterns, checklist usage, navigational practice. Is their progress normal? If it is, you go on to 6. If it's not, you kind of hold them back and say, here's what we need to work on. We're not ready to go to lesson 6 because we start to get into more stuff and you're not ready yet. So we need to, do whatever the retraining is or additional training is. Okay, that's it for 5. Any questions?